All right, so what we're gonna do, like I said, we're gonna cover, come on, wake up, camera, get focused here. There we are. All right, so like I said, we're gonna start chapter 7. Tonight we're gonna cover 7, 1, 2, and 3. Hopefully we can get that all done. This should go pretty straightforward because chapter 7 is all about radicals. Radicals, another way to say it, what a lot of people are more familiar with is roots, like square roots and cube roots and fourth roots and fifth roots and all of that. So radicals, or your roots, are the opposite of an exponent. So what I mean is, okay, if we take 3 to the second power, well, that means 3 times 3, okay, which is 9. So in math, typically when they give you some kind of operation, they give you something that will undo it. For example, with addition, we undo with subtraction. For multiplication, you undo with division. You got inverse, opposite operations. So same thing, if I want to figure out what number times itself is 9, the operation is to take the square root. So this is the square root. Okay, and what this is trying to figure out is what number times itself is 9. And of course, we just showed that would be 3. So when you see no index or no number out in front, it's automatically a square root. You're trying to figure out what number times itself equals the number inside. Okay, you're familiar, there are lots of square numbers. For example, the square root of 25. What number times itself is 25? That would be 5. Square root of 144. Okay, what number times itself is 144? Okay, if you don't know square roots, like right off the top of your head, calculators will do these now. So they have those operations baked into calculators. Now, each calculator is a little bit different in how they figure it out, but at some point, somewhere on your calculator, you have a square root button, like so. Okay, and the way my calculator works, you hit that square root button. Can't really see it very well. There we go, in the light, you can kind of see that there. It'll give me a square root symbol. I type whatever I want to inside, hit equals, and it'll break it down for me. So the square root of 144 is 12. So any scientific calculator will have a square root button on it. So you need to figure out how your calculator works. If you're not sure, send me a screenshot of your calculator and I can actually kind of walk you through it. It's not that big a deal. Okay. Now, there are more than just square roots. Okay, for example, they could give you an index here and say something like, all right, the cubed root of 8. So when they give you an index, it'll be a little number right up here. And again, what this implies is what number times itself 3 times is 8. So again, that's a cubed root. Well, 8 is 2 times 2 times 2. All right, if you think about that. Okay, 2 times 2 is 4, 4 times 2 is 8. So the cubed root of 8 is 2. Now, don't confuse an index number, okay, with a multiplier. All right, so if they put a cubed root, they'll do it like that. If they say something like this, so if the number is basically the same size as that inside number, this means 3 times the square root of 4. This means the cubed root. So kind of like how exponents are smaller and up above, your index is a smaller number above the square root part right here. Whereas if they write it out in front, this means, okay, 3 times that square root of 4, which the square root of 4 is 2. So that would ultimately be 6. Okay, so anyway, don't confuse an index number with a multiplier. Okay, so sometimes they'll write a number out in front, and that means 3 times whatever the heck. If they put a number up here, that means what number times itself that many times is that number. Likewise, if they said something like, what is the 6th root of 64? So again, that implies what number times itself 6 times is 64. Okay. Now, again, your calculator will have a button for that as well. It's typically really close to your square root button. So on mine, if you look at the yellow right up here, you see a square root with a box. Okay, you'll see somewhere on your calculator, there will be a button, and sometimes it's above it. You'll see a square root with like an X, or sometimes they use boxes, but that way you can type your index in. So again, with my calculator, I'll try to do this where you can see it. I can get it in the light there a little bit. So for the 6th root, okay, I hit my thing and it draws my little square root thing here. I can type in that index number, and I can type in that 64, and I can hit equals, and my calculator will do that. So your calculator should be able to evaluate various roots. So the 6th root of 64 is also 2. So anyway, if you get stuck and you're not sure how to use your calculator, send me a screenshot of what kind of calculator you have, and I can kind of walk you through it. Okay. Or heck, you can YouTube just about anything, and YouTube will walk you through just about anything as well. Okay. So that's how you can use your calculator to evaluate perfect roots if it's not something you know. For example, most people know the square root of 25 is 5. But for example, let's say you didn't know the square root of 144, or if they give you some gigantorific number, okay, your calculator can do that. Now, occasionally, they will give you a non-perfect square. For example, if they ask for the square root of 17, okay, most of the time, in fact, the rest of this unit, I'm going to want the exact answer, which is just the square root of 17. That one doesn't simplify. If it asks you to approximate this, and it'll specifically say where to round. If it says to round to the nearest thousandth, okay, that implies 3 decimal places. So your decimal places go tenths, hundredths, thousandths, okay? So most of the time, okay, within this chapter, you're not going to give me the decimal approximation, but there are a couple of problems, I think, within your homework tonight for 7-1, where they specifically say to approximate and round to the nearest thousandth. So if you type in the square root of 17 and hit equals, my calculator simplifies it to the square root of 17. It doesn't want to give me the decimal, but if I hit my S to D button, that'll change it. And I can write this as a decimal. So that is about 4.1231. So again, if I look at the next number, if that's 4 or smaller, then we just drop it off. If it's 5 or bigger, then we round up. So this would be my approximation. Okay, so there are a couple of problems within this section where they want you to approximate. You are going to need a calculator for that. Now, when I get to 7.3, we're going to talk about simplifying non-perfect roots, and that's primarily what I want you to do, but just only in a couple of problems do you approximate. All right, now, if it was only perfect roots, or if it was only numbers, math would be ridiculously easy. But of course, this is an algebra class, so they're going to throw some letters at you. So to deal with letters, for example, if they asked me to find the cubed root of x to the 12th, or any variable to any power, really, okay? Variables behave differently than your whole numbers. Remember, this is based off of kind of those power rules. So I'm going to just remind you, remember when we multiplied exponents of the same power or of the same base, shortcut was to add those exponents together. Okay, so similarly, if we're taking the cubed root of this, we can just straight up divide. Basically, we need to figure out how many times 3 goes into 12. So the cubed root of x to the 12th is x to the 4th. You just divide. You take your exponent divided by your index. So 12 divided by 3 is your 4. And they can give you a ton of variables, and you would do the same thing. For example, if they asked me to find the 5th root of x to the 5th, y to the 10th, z to the 25th. For each individual variable, you just divide the exponent by the index or the root number. So in this case, 5 divided by 5 is 1. So that's going to be an x to the first. 10 divided by 5 is 2. So that would be a y to the second. 25 divided by 5 is 5. So that would be a z to the fifth. So variables and exponents, okay, you just simply divide your exponent by your index or your root number. Okay. Now, if they mix these things together, or here, let's do this. If they don't show you the index, okay, this is where it's going to be important to know. Remember, I said if there's no index number, it's a square root. So if you don't see an index number, it's automatically a 2. So if they don't show you any kind of index number here, they just say, what's the square root of x to the 8th, y to the 10th? That index is an implied 2. So then that would be x to the 4th and y to the 5th. Now, again, where they try to get tricky with these is they're going to combine stuff. So they're going to ask you for the square root of 64, a to the 8th, b to the 10th, c to the 2nd, something like that. Okay, when we do this, we're actually going to treat this like it's 2 separate problems. Okay, whole numbers, coefficients behave differently than your variables and exponents. Okay, so this square root of 64 is asking me, okay, what number times itself is 64? Okay, 64 is 8 times 8. So the root of 64 part is 8. Okay, then the variables and exponents, we do that division. So again, if you don't see an index, it's a 2. Then we divide. So 8 divided by 2, that would be a to the 4th. 10 divided by 2, that would be b to the 5th. And 2 divided by 2, that would be c to the 1st. Now remember, with an exponent of 1, you don't have to write it. Okay, it can, but you don't have to. And it would be the same if they gave us a different index. For example, if they said the 4th root of 2,401 x to the 8th. Okay, again, I don't know the 4th root of 2,401 right off the top of my head, so I would go to my handy dandy calculator, hit my radical button up there, type in my index, and 2,401. Okay, that 4th root is 7. Now this I can do, so 8 divided by 4 is 2, so then that would be x to the 2nd. So whole numbers, we actually take the square root of exponents, you just simply divide by your index. The only other real thing they can do to kind of monkey with you here is they can start, well, they can give you fractions, or they can start messing around with negatives and stuff like that. So negatives, if the negative is out in front, for example, if they ask for the negative square root of 16, okay, this is just an outside multiplier. So this is just going to take the square root of 16 and then make it negative. For example, the square root of 16 is 4. The negative out in front just makes it negative. Okay, same thing. They may give you a new symbol. If you've got like an underlined plus, okay, that is your plus and minus. What that means is both the positive and the negative answer. So again, if it's out in front, it just takes your answer and makes it both the positive and the negative. So the cube root of 125 is 5, and then you can write that symbol out in front. So that means plus or minus 5. And again, what that implies is both positive 5 and negative 5. So just instead of writing them separately, just gives you a way to write them both at the same time. It's just a different kind of symbol. Now, the issue we run into is when the negative is inside of the radical. For example, if they said the square root of negative 16. Okay, here we run into problems. If the index is even, so if this number here is even, for example, if you don't see a number, remember it's a 2, or if it's a 4 or a 6 or an 8, and the negative is inside, then this is not real. We don't have a real number, then we can multiply by itself to get a negative 16, because if you multiply two positive numbers, you get a positive answer. Likewise, if you multiply two negative numbers together, you also get a positive answer. So we don't have a number in our number system where you can multiply it by itself and get a negative answer. So then this is a not real solution. Now, we will eventually talk about imaginary numbers, but for this section, if they give you a square root or a fourth root or a sixth root of a negative number inside, you just say that your answer is not real. When we get to the point where we talk about imaginary numbers, I'm going to expect you to be able to do that, but not until then. So if they said, what's the fourth root of negative 625? Really doesn't matter what number they put here. You just say that is not real. Now, on the other hand, if the index is odd, for example, if they said something like the cube root of negative 8, then we do get a solution. Okay, this is asking what number times itself 3 times is negative 8. Well, if we take negative 2 times negative 2 times negative 2, okay, negative 2 times negative 2 is positive 2 or positive 4, but 4 times negative 2 is negative 8. So again, if you have an odd index, you can get negative solutions. That's not a problem. The thing is, if it's even, the negatives cancel each other out and you end up with a positive solution. There's no way to get a negative. If it's odd, then it's perfectly fine. So if they said the fifth root, oh, sorry, the cube root of that would be negative 2, not negative 8. So that's the answer. I'm sorry. So the cube root of negative 8. So negative 2 times negative 2 times negative 2 is negative 8. So the answer, the cube root of negative 8 is negative 2. So likewise, if they said, what's the fifth root of negative 32? That would be negative 2. And again, your calculator can generate that kind of stuff too. For example, if I try typing in the fourth root, let's see it very well. So if I tried the fourth root of negative 16, oops, how if I put my number in the right place? Negative 16. It says math error. That's not real. It can't do it. So my calculator runs into issues. Okay. But if I said the fifth root of negative 32. Okay, my calculator can totally do that. Okay, so you can do stuff, especially in 7.1 with your calculator. All right. They do throw a couple of questions in here asking about the graph and or the domain of a square root function. Okay. Remember, with the graphs, you can go to Desmos. Desmos will totally graph it for you. But the graph of a square root function looks like this. Okay, it definitely has a stopping point because you can't put negative numbers inside of a square root. So with this, once you get over here, if you try plugging in negative x's, there's no real solutions. That's why there's no graph over here on this side. Okay, and this just means to take the square root of whatever you put in there. So if I plug in 1, the square root of 1 is 1. If I plug in 4, the square root of 4 is 2. I plugged in 9, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. So anyway, that's what your square root graph would look like. Okay, if they ask for the domain of this function, we did graphs of domains, so we never go left of 0, but we go forever right. So then your domain would be from 0 to infinity. Okay, if they do some stuff within the graph, for example, they said the square root of x plus 2 plus 3, then it's going to be a similar graph. So basically this same shape, but it's going to shift. So any number inside of the radical is going to shift the graph left or right. Any number outside of the graph is going to shift the graph up or down. Now, inside of the radical actually does things a little bit backwards. A positive number will actually shift it to the left, which is backwards to what we think, because negative numbers are this way. But actually, if this is a plus, this is going to shift my graph 2 units to the left. Okay, if this was a minus, that would actually shift it to the right. Outside, positives shift up, negatives shift down. So this particular graph is going to give me this same curve, but it's going to move 2 units to the left and 3 units up. So my graph is going to start there. Then we go over 1 and up 1, over 4 and up 2. And would look like that. So again, if they asked me for the domain of this function, we never go left of -2. We go forever right. So my domain would be from -2 to infinity. Now, if they ask me to graph a cube root, it actually looks something like that. Okay, because again, odd indexes, you can put a negative inside, so this graph actually does keep going. Okay, so the domain for this one, you go forever left, you go forever right, so your domain is actually all real numbers. And again, the same kind of shifts. If they told me to sketch the cubed root of x minus 3 minus 4, same thing. Inside is going to shift left and right, backwards, so positives would shift left, negatives would shift right. The number outside shifts you up and down, positives go up, negatives go down. So this is going to take my same cube root graph, but now it's going to move 3 units to the right, and it's going to move 4 units down. Everything else stays the same. And again, if they ask for the domain, your domain goes forever left, forever right. It hits all real numbers. All right, that's 7.1. I'm actually going to jump in order because I want to go to 7.3, because 7.3 does a lot of the same stuff, but instead of always being perfect squares, 7.3 deals with simplifying non-perfect roots. For example, if they told me to give the square root of 50. Now, in this section, we want exact answers. Do not give me a decimal approximation. Okay, for example, I'll show you on my calculator, because my calculator actually does simplify squares. It doesn't do cubes or anything like that. But if I type in the square root of 50, my calculator says 5 square roots of 2. That's the answer I want. This is an exact answer. This is a simplified root. Okay, if you type in the square root of 50 into your calculator and it gives you the decimal approximation of 7.071-ish, okay, that is an approximate answer. Again, in 7.1, they ask you specifically for the approximate answer a couple of times. Only in 7.1, okay? After that, from here on out, I want you to give me exact answers. I don't want this approximate answer, okay? This is the correct simplified radical answer. This is what I want, okay? Now, how to get there without using the calculator. If you have a calculator that does square roots, awesome, you can totally use it, okay? If not, there's a process we can do. It's not difficult, okay? What we're going to do is we're going to take our inside number and we're going to break it into its prime factors. What that means is we want to find numbers that we can multiply to get this, and we're going to keep doing that until we can't break down anymore. Now, when I say that, don't use 1. Okay, 1 times anything is itself, and you could go with ones forever. So anyway, what are 2 numbers that I can multiply to get 50? And it doesn't matter which 2 you pick as long as they multiply to get 50. And I want whole numbers, not decimals. So for example, 50 is 5 times 10. Okay, 10 is 2 times 5. Now, these numbers are done because they are prime. What that means is there is no number I can multiply to get 5 besides 1 and 5. That isn't a fraction. Like obviously I can take 2 times 2.5, but that's not what I'm looking for. I'm looking for whole numbers. So the only whole numbers I can multiply to get 5 are 1 and 5. So this is a prime number. Okay, 10 I can keep breaking down. 10 is 2 times 5, but 2 is prime and 5 is prime. I can't break those down anymore. So then what you're looking for a square root, you're looking for pairs. If I have a pair of numbers, that goes out in front, and anything left over stays inside of the radical. So again, these perfect pairs means that makes a square root, okay? That's why that comes out in front. And anything that doesn't have a pair, okay, does not come out of the square root, therefore stays inside. So the square root of 50 is 5 square roots of 2. Okay, if I do another one of those. Okay, for example, if I want to take the square root of 4,410. Okay, Again, I want to break this into its prime factors. So I'm looking for any number besides 1 that I can multiply to get 4,410. So on my calculator, I'm just going to start dividing. Well, I know it's even, so I'm going to take 4,410 divided by 2. Okay, so this breaks into 2 and 2205. I know 2 is prime, so that one can be done. Okay, that 2205. I hit divide by 5. Okay, I get 441. You know, 5 is prime. I'm gonna see if I can multiply something into that 441. Divided by 2. Nope, get a fraction. So try again. 441 divided by 3. There we go. I get 147. Same thing. If I divide that by 3. All right. I get 49. Okay, and I know 49 is 7 times 7. So these are all of my prime numbers. These numbers don't break down anymore. You wouldn't have to go in the same order. When you break a number down into its prime factors, you're always going to get the same numbers. I might get them in a different order. So if I would have divided by 7 first, this would have gone in a different order, but I would have still ended up with the same numbers. So there's no magic process to do that. You're just finding what numbers would multiply to get this. Anyway, again, with a square root, I'm looking for pairs. For example, I have a pair of 3s. So that would go out in front. I have a pair of 7s. That would also go out in front. Then my poor 5 and 2 that don't have any buddies, they're left over inside. Okay, so again, when you have a pair, you just write that number out in front. When you have a pair of 7s, you write that number out in front, not both of them. And the numbers that don't have pairs stay inside of the radical. If you have more than one number, when it's all said and done, you're going to multiply them. So 3 times 7 is 21. 2 times 5 is 10. So this is 21 square roots of 10. So if your calculator does that for you, that's pretty sweet. For example, if I type in the square root of 4410 and I hit equals, my calculator says 21 square roots of 10, which is what we got. Okay. It's the same process for cube roots and fourth roots and fifth roots. The only difference is how many you're looking for. For example, if I wanted to simplify the cubed root of 120. Now, this is also one of those things I wanted to point out, because even though my calculator does square roots, if I try doing the cubed root of 120, my calculator doesn't know how to do that. And I don't want the decimal approximation. So don't give me a decimal. That's no good. So this one, I actually have to do that process. I can't take it on my calculator. So I got to find two numbers that multiply to get 120. 120 is 2 times 60. 60 is 6 times 10. 6 is 2 times 3. 10 is 2 times 5. So these are my numbers that don't break down anymore. 2 and 2 and 3 and 2 and 5. And again, if I did this in a different order, I would still end up with these same numbers, just in a different order. Now, the difference is for a cubed root is I'm no longer looking for pairs. I'm looking for 3 of a kind. Okay, pairs don't matter. But if I've got 3 of something, then that goes outside. And again, any little leftover guys stay inside. So the cubed root of 120 is 2 cubed roots of 15. and pluses and minuses and negatives still work. So if this would have been a negative, that would just make your answer negative. Okay. Or with a odd index, if they put a negative inside, that would have just made my answer inside negative. Okay. So anyway, variables. If they asked me to simplify the cubed root of x to the 5th power, we still divide, okay? However many times it goes in evenly, it was what comes out in front, and then leftovers or remainders stay inside. So what I mean by that is we divide, so you take your exponent divided by 3, so 5 divided by 3, well, 3 goes into 5 once with 2 left over. So however many times it goes in evenly is what comes out in front, and then any remainder is what stays inside. And then you could do that for each variable. For example, if they asked for the 4th root of x to the 7th, y to the 8th, z to the 9th. Okay, 4 goes into 7 one time evenly with 3 left over. 4 goes into 8 twice evenly with none left over. And then 4 goes into 9 twice with 1 left over. Also notice, kind of did so without paying attention, whatever my index is stays with the problem. So that cube root stays as a cube root. If you forget that, then you're turning a cube root into a square root. We don't want to do that. Same thing, my 4th root stays a 4th root. So keep your index with your radical. And if they combine those two concepts, okay, we're still going to do the same thing. Now, here's also kind of how I do this, because most of these are going to simplify. I go ahead and draw my square root, and I talk about things in terms of what goes outside or out in front compared to what goes inside. Okay, and again, I'm going to look at this like 2 separate problems. I'm going to do the whole number piece first. So 45, okay, 45 is 9 times 5. 9 is 3 times 3. So again, my pairs go outside. Anything left over stays in. So that square root of 45 is 3 roots of 5. Variables and exponents, remember I just divide. If you don't see an index, it's a 2. Okay, divide, 8 divided by 2. It goes in 4 times evenly. 7 divided by 2, it goes in 3 times with 1 left over. Now I didn't do a very good job, but make sure that 3 stays with the b and does not look like a cubed root. So really it should look more like 3a to the 4th, b to the 3rd, and then the square root of 5b or 5b to the 1st. I try to leave a space big enough in here so this doesn't look like it's a cubed root. Because when I write it like this, like it's kind of tough to tell whether that's a root or a not. So just be careful of that. All right, the last section is 7.2. So I'm going to jump to 7.2, and 7.2 is doing more of the same stuff. but it just writes it a different way. So 7-2 deals with rational or fraction exponents. Okay, rational exponents are the same as roots. For example, x to the 3/5 power means, okay, whatever your bottom number of your fraction is the root number. And then if there's a numerator to the fraction, that becomes your exponent. So x to the 3/5 power means the 5th root of x cubed. So basically, these are just another way to write each other, and you should be able to work in both directions. There's a couple of times they ask you, hey, write this as a rational exponent. This is what we're looking for. Sometimes they're like, hey, write this as a radical. This is what we're looking for. Okay. Now, the good news is there are some problems where they give you whole numbers and just tell you to simplify it. For example, they try to give you something difficult like this. So 256 over 625 to the 1/4 power, which looks kind of difficult. But the cool thing is, if you're dealing with just numbers and no letters, your calculator can totally do this. So if I type in a parentheses, fraction button, 256 over 625, oops, close my parentheses, to the 1/4 power, just like it shows. I hit equals. My handy dandy calculator says that's 4/5. Okay, so you don't even really have to know how this works for it to work. Now, again, I can show you how this works. So again, the 1/4 power means this is the 4th root of 256 divided by the 4th root of 625, which the 4th root of 256 is 4. Okay, the 4th root of 625 is 5, and you would get the same thing. But again, if you're just dealing with numbers, your handy dandy calculator will totally do that for you. Now, when they start mixing in numbers and variables, you have to remember how exponents work. For example, this actually kind of ties into, I think it was last chapter when we did the properties of exponents. Because this is written as an exponent, it's still going to follow those properties. So again, 36 x to the 4th power to the 1/2 power means, okay, we're going to take 36 to the 1/2 power, and we're going to take x to the 4th to the 1/2 power. We're basically taking both of these things to this power. Now remember, your whole numbers behave differently than your variables. So 36 to the 1/2, again, just numbers, we can do this in our calculator. So 36 to the 1/2 power is 6, which makes sense because 1/2 is the same as square rooting it. But remember, if you're taking an exponent to a power, you multiply those. So x to the 4th power to the 1/2 power, you multiply 4 times 1/2. We would get 2. Now, again, thinking about it this way, the 1/2 power means the square root, because there's your power, there's your, or sorry, there's your index, there's your power. So this means the square root of 36x to the 4th, which just like we showed before, is 6x to the 2nd. Okay. Now they're going to do a couple of things to try to monkey with you. All right. when you have parentheses, okay, we're taking all of this stuff to this power. So again, we've got to take 9 to the 1/2 power, which is 3. We take 1/2 to the 1/2 power. Remember, we multiply exponents, so that would be m to the 1/4. Now, if they want us to write it as a radical, okay, understand that if there's no parentheses, that power only applies to that variable. So then this would be the 4th root of m to the 1st. The 3 stays out in front. Likewise, if there's no parentheses, the only thing this 1/2 power goes to is the m. Okay, this 9 is out here all by itself. So this means 9, and then m to the 1/2 means the square root of m to the 1st. Okay, now again, you don't ever put, I would say you don't ever, you typically don't put the 2 here for a square root. You typically don't put the 1 here for an exponent. So we would just write this as 9 square roots of m. Okay, the 2 and the 1 are implied. But they're going to try to trick you by either having parentheses or not. Remember, if they have parentheses, then everything is taken to the power. If there are no parentheses, it only goes to what it's right next to. Now, if they give you something silly like this, okay, you do have to remember those power or properties of exponents, stuff we learned. Okay, remember, if we're multiplying and the bases are the same, the shortcut is to add those exponents together. And then remember, if we're dividing, that means to subtract. So we can simply write this as x to the whatever the heck that is. So if I take 1/3 plus 1/3 minus a negative 1/3, which remember subtracting a negative is adding. So 1/3 plus 1/3 is 2/3, plus another 1/3 is 3/3, and 3/3 is just 1. So they're going to ask you to simplify using your properties of exponents. You need to make sure you remember how to do that. All right, that's basically the first 3 sections of chapter 7. That's stuff you should be able to do. So again, 7.1, you're primarily going to be dealing with perfect roots. They do throw in a couple of the graphing problems, and they throw in one problem where they say, what's the decimal approximation? 7.3 is the one where you're breaking down non-perfect roots. And then 7.2, they're going to give you a bunch of fraction exponents, and they're going to expect you to remember your properties of exponents. So just real quick as a refresh / reminder, your properties of exponents are, if you're multiplying, whoa, lost focus, come on, wake up. Okay, if you're multiplying exponents of the same base, that shortcut is to add those exponents together. If we're dividing, okay, that shortcut is to subtract those exponents. And if you're taking a power to a power, that shortcut is to multiply those exponents. And that's regardless of what kind of numbers they have, okay? In that lesson, they're specifically going to give you a bunch of fraction ones, but it all behaves the same. So if they give you something like x cubed y squared to the 1/4 power over x to the -5 y to the -1 to the -1/2 power. Sorry. Okay, we need to be able to simplify this. So again, power to a power, we multiply. 3 times 1/4 is 3/4. 2 times 1/4 is 1/2. -5 times -1/2 is 5/2. -1 times -1/2 is 1/2. And again, now we're dividing, so we need to subtract our exponents. So if I take 3/4 minus 5, whoops, hope if I type this in right, 3/4 minus 5/2, I get -7/4. And then 1/2 minus 1/2 is 0, so that y goes away. Remember, negative exponents we can't use, so we're going to write this as 1/x to the 7/4. So all those same properties that we learned, okay, still apply. They're going to expect you to use those. They're just going to give you fractions to do it with. Okay, so again, that's 7, 1, 2, and 3. Again, double check. Remember, there's a handful of you who have still not tested over chapter 6. Remember, you need to set up an appointment with the testing center and get that taken care of. We covered 7, 1, 2, and 3 this week. Next week, we will cover 7, 5, 6, and 7, I think, or 4, 5, and 6. I can't remember. We'll cover the next 3 sections. Then you get Thanksgiving break off. But we do have class next Thursday. Make sure you're here. We'll cover the next 3 sections of chapter 7. So anyway, if you don't have any questions for me, that's all I got for you guys. If you have questions, I'm going to stick around for a little bit. You can ask them, but otherwise, that's all I got. You're free to go. Appreciate it.